Welcome to our new topic. We're going to be talking about how we get iron and other metals from the earth. So we go and mine it out, we go and dig it up, and it's combined with a whole bunch of other stuff. Now, how do we actually get the iron, the element, just Fe? How do we extract that from rock that we find in a mine? So we're going to talk about that. I hope you can hear me okay, this mic. Testing out a new mic today. We're going to go find out how we do this in chemistry. So let's get straight into it. All right, so here's your topic. It's called extracting metals like iron, but we can also talk about other metals like aluminium and talk about other metals like zinc from ore. So what the heck is ore? So ore is basically just a solid material that contains a metal. So here we've got pyrite. This has got iron part of it, and then we've got magnetite here. It's also got iron. These are two different types of ores. Okay, so we can go and mine this, and what we want to do is we want to try and get this iron from this ore. You do get metals called native metals. Whoopsie, native metals, which are unreactive. In other words, they don't really react with anything like oxygen or sulfur or anything like that, and they are found just by themselves. Okay, so this is the topic that we're going to be talking about. Okay, there's some learning objectives here. We've basically talked about the first one already. Okay, that most metals are extracted from ores, like I've mentioned, and that some unreactive metals like gold and silver are found just as an uncombined element. We're going to explain the method of how to extract a metal. Okay, I'm going to show you a big old furnace, which is like a big oven, and how they use these techniques in this oven to extract iron. We're also going to talk about electrolysis again, articulate on a metal extraction process. Again, this is to do with iron, and then we are going to use we're going to talk about the uses of aluminum, copper, and iron and steel in terms of their properties. Okay, cool. We need to get straight into this. So here we go. We can have a piece of ore, a zinc sulfide over here. How do we get the zinc sulfide into zinc? It's a two-step process. The first step is that you have to turn this zinc sulfide into zinc oxide. And to do this, we simply burn it in oxygen. And burning it in oxygen is called roasting. Okay? Now, once it is into a zinc oxide, we can use another process I'm going to explain in a second to turn it into zinc. I just wanted to mention that most metals are in the form of an oxide. For example, we have this iron is as part of this compound, and this is an oxide of iron. And what we can do then is we can take this iron and we can transform it into pure iron. This compound of iron oxide, and we can transform it into iron. I'm going to show you that process now. Okay, it involves the reactivity series. So what is the reactivity series? Let's go through it again. Okay, remember that if one element is above another element in the reactivity series, it will displace it. In other words, if we've got something like zinc oxide, okay, we talked about zinc oxide. Now, zinc is over here. If we burn this with carbon, what carbon is going to do, it's going to jump in the place of oxygen, okay, and it's going to form carbon dioxide. What's that result gonna be? It's going to result in the pure form of zinc. So we've extracted the zinc from the oxygen. Okay, so we can do this for iron, and we can do this for copper, and we can use carbon to do this. Now, why we use carbon is it's an inexpensive substance. Okay, and we try to save money here when we are developing these metals. Okay, so a quick little recap on oxidation and reduction. So this is important. Oxidation is the loss of electrons and reduction is the gain. So what is happening? What is getting reduced and what is getting oxidized in this equation? This is important to know. Have a look here. Okay. We know that zinc oxide is a ionic compound. We know this because it's got a metal and a non-metal. And when these two react, it's because the zinc has a 2+ charge and oxygen has a 2- charge. These two form together. Now, what happens in this reaction when zinc oxide actually forms zinc? Well, what's happening here is the zinc 2+ ion is becoming neutrally charged. Okay, sorry, this should have little z's. Now, how does one go from 2+ to a neutral charge? It has to have gained negativity, right? In other words, it has to have gained electrons. Now, when something gains electrons, we call it reduction. So this is the reduction over here. The carbon is going from being neutral to being 2- over here. For it to be as part of carbon dioxide, it needs to be 2-. Okay, that's not actually true because this is a covalent bond. So let's, for now, just think of this as carbon becomes oxidized